Good morning children. In today's class we are going to learn some multiple choice questions under matrices. If A equals 1, 2, 3, then the rank of A transpose. Let us find out what is A transpose. A is 1, 2, 3. A transpose will be interchanging rows and columns. So this is a row matrix. This will be a column matrix. As I multiply, I get row by column. 1 into 1 plus 2 into 2 plus 3 into 3. As we simplify, it is 1 plus 4 plus 9, or it is 14. It has one row, one column, and obviously this element is not 0. So rank of A transpose is 1. Why do I say 1? It has only one row and one column. So obviously the rank must be equal to 1 or below 1. If it is 0, my answer is 0. If it is a non-zero element, my answer is 1. You need not even calculate all this. You can simply say A transpose. A, the rank is 1 row, 3 columns, 1 by 3. A transpose by interchanging, it is 3 by 1. So when I multiply, the number gets cancelled. My answer for A transpose will be 1 by 1. It has one row and one column. Immediately you can say the rank is 1. Provided the answer to this should not be 0. Here all the numbers are positive. When I multiply positive numbers by positive numbers, my answer will not become 0. So without even calculating, you can simply say the rank is 1. Option D is the right choice. Question number 2. The rank of M by N matrix whose elements are unity. What do you mean by the word unity? It goes 1, 1, 1 and so on. Every element, it is 1, 1, 1 only. So this is a M by N matrix. Whatever be the number of rows and columns, if all the elements are equal to 1, however I take the determinant, my answer will be 0, because every row is identical to the other, or every column is identical to the other. Even if I take 2 by 2, 1 into 1 minus 1 into 1 is 0. So such a matrix, the rank is obviously 1 only. If all the elements are 4, now also my answer is 1. If all the elements are equal to a same number, here it is unity, even if it is 4, fully 4 or fully 3, then also we will declare row of A is 1. Option B is the right choice. Question number 3. Transition probability matrix is given. At equilibrium, we want to find what is A. What do you mean by equilibrium? We will say A, B, I start. I multiply the transition probability matrix. My answer is again A, B. Let me compare first row by first column. So first row by first column, as I multiply 0.4A plus 0.2B, and my answer here is A. First row by first column gives me the first element. Wherever B comes, I can very well put 1 minus A. In transition probability, A plus B is always 1. So B, I can very well write 1 minus A. Now 0.4A plus 0.2b equals a. I can rearrange 0.2 into wherever b comes, I am writing 1 minus a. This 0.4a, let me take to the other side. Already it was a. Now I am bringing 0.4a. How shall I subtract? 0.2 into 1 minus 0.2 into a equals. Here no number tells me 1. 1a minus 0.4a. 1 minus 0.4 is 0.6a. Bring this 0.2a to the other side. I get 0.2 equals 0.6a plus 0.2a, or we get 0.6a plus 0.2a is 0.8a equals 0.2. My question is to find out a, that is 0.2 divided by 0.8. As we cancel 1 divided by 4. So option A is the right choice. Question number 4. If A equals 2008, then row of A is. To find the rank, let us check how many rows and columns are there. 2 rows and 2 columns. Obviously, rank will be less than or equal to 2. When I find the determinant 2 into 8 minus 0 into 0, my answer is not equal to 0. 2 by 2 minor is not equal to 0. Declares rank is 2. Option C is the right choice. Question number 5. Given a matrix like this, we need to find the rank of it. Let us find the determinant. Because it has 3 rows and 3 columns, it is easy for us to find the determinant. 1, 2, 3, 1, 4, 9. As we expand, plus, minus, plus. 1 into, hide the row and column. I get 2, 3, 4, 9. Minus 1 into, hide the row, hide the column. 1, 3, 1, 9. Plus 1 into, hide the row, hide the column. I get 1, 2, 1, 4. As we expand, plus 1 into 18 minus 12. Minus 1 into 9 minus 3. Plus 1 into 4 minus 2. As we simplify, 6 into 1, 6 into minus 1, 2 into 1. My answer is not equal to 0. Whenever it is a 3 by 3 matrix, rank will be less than or equal to 3. When the determinant is not 0, it has 3 rows, 3 columns, the determinant is not 0, immediately declare the rank is 3. Third order determinant, or I can say minor, which is not equal to 0. Rank is 3 and option D is the right choice. Question number 6. Rank of the unit matrix of order n. We know I2, the second order unit matrix 1, 0, 0, 1. What is the determinant of I2? It is 1 minus 0, that is 1, which is not equal to 0, and the rank of I2. There are 2 rows, 2 columns. The determinant is not 0. Rank is 2. When I say I3, it is 1, 0, 0, 0, 1, 0, 0, 0, 1. Again, I know determinant I3. Diagonally I multiply, my answer is 1, which is not equal to 0. So, when it has 3 rows and 3 columns, my answer is 3. Now the question is, matrix of order n. So, and so on, let me put IN. The rank is n. When it is I2, the rank is 2. When it is I3, the rank is 3. So, when there are n rows and columns, the rank is n, and so option B is the right choice. Question number 7. Row of A is R. So, when I read the question, what do I understand? When the rank is R, I declare there is at least one minor of order R that does not vanish. At least one minor. Check which answer suits our statement. At least one minor of order R that does not vanish. So we have B option to be the right choice. At the same time, let us check the other options are wrong. We know this is the right option. Anyway, let us check the other 3. All the minors of order R which does not vanish. We know at least one minor which does not vanish is enough. So all the minors is a wrong condition. Sometimes all the minors, but we need a minimum of one minor. So option B will be the very much suitable choice than this one. So this is not true in all the cases. Option number C. At least one or plus one order minor which vanishes. Here we should have had all the r plus 1 order minor should vanish. Given at least one is wrong, all the r plus 1 order minor should vanish. And the last one, all r plus 1 higher order minors should not vanish. Actually, should vanish should come. Should not vanish given, so that is also wrong. So out of the 4, at least one minor of order R which does not vanish is the suitable choice. Question number 8. A is equal to 1, 2, 3. How many rows? 1, 2, 3 rows. And how many columns? There is only one column. My question is to find the rank of A transpose. Let me find out. A transpose. A is 1, 2, 3. What about A transpose? The column will become row. We are interchanging rows and columns. What is the order of A transpose? It is 1 by 3. This is 3 by 1 and this is 1 by 3. When I multiply, 1 and 1 will get cancelled. My answer will have 3 rows, 3 columns. When I multiply, this is A which is 1, 2, 3. A transpose is 1, 2, 3 but it is a row matrix. Here there are 3 rows and 1 column, whereas here 1 row and 3 columns. As I multiply, 1 and 1 will get cancelled. We are left with 3 rows and 3 columns. How am I to write the product? First row by first row by second row, first row by third row. 1 into 1, 1 into 2, 1 into 3. Now, second row by first, 2 into 1, 2 into 2, 2 into 3. Third row by first, 3 into 1, 3 into 2, 3 into 3. So, I have achieved 3 rows and 3 columns. What is the determinant of A transpose? Obviously, my answer 0. Why? Because row 1 proportional to row 2, proportional to row 3. Row 1, row 2, row 3. See, this is 1, 2, 3. I multiply by 2, I arrive at this. I multiply by 3, I arrive at this. All the 3 rows are proportional. So, the determinant will obviously be 0. Even if I take 2 by 2 minus, what do you mean by 2 by 2 minus? Hiding a row, hiding a column. I arrive at 2 by 2. All the 2 by 2, however I hide, my answer will be 0 because all the rows are proportional. Even if I hide first column or second row, however I hide, my answer is going to be 0. So I can immediately declare row of A transpose. Third order 0, second order 0. So my answer is 1. Rank of A transpose is 1 and option B is the right choice. Question number 9. If the rank of the matrix is 2, then lambda is. When I say the rank is 2, all the higher orders must vanish. Rank is 2 declares third order must vanish. So let me write the third order determinant, that is lambda minus 1 0, 0 lambda minus 1, minus 1 0 lambda, that is equal to 0. As I expand, I get plus minus plus. Lambda into, hide the row and column, it is lambda square minus 0. Minus of minus 1, I will write plus 1 into, hide the row, hide the column, 0 minus 1. 0 into anything 0, so I need not multiply. My answer is 0. Because RHS 0, I am just putting 0. So I have expanded the determinant, equated to 0. As I multiply, lambda into lambda square, lambda cube, plus 1 into minus 1, that is 0. So this tells me lambda cube is equal to 1, or I will say lambda equal to 1. So whenever lambda is 1, this matrix is of rank 2. So my question is rank 2. So the right choice is lambda equal to 1. Question number 10. The rank of the diagonal matrix. What do you mean by the word diagonal matrix? Other than the main diagonal, the remaining elements are 0. So here and here the elements are 0. Again in the diagonal also there are 3 zeros. So let me count how many non-zero elements are there. 1, 2, minus 3. So this determinant 1, 2, minus 3. All the remaining are zeros. When I expand, it is a diagonal matrix. Expansion tells me multiply it diagonally. 1 into 2 into minus 3. My answer is minus 6, which is not equal to 0. So there are 3 non-zero elements. With that, I created the diagonal matrix, for which I found out the minor. There are 3 non-zero elements along the diagonal. So it has 3 rows and 3 columns. So I will say third order minor is not equal to 0. Rank of the matrix is 3. Simply to say, for a diagonal matrix, count how many non-zero elements are there along the diagonal. 1, 2, minus 3. 3 non-zero elements will declare the rank is 3. And we have given the explanation, but it is good to remember it as an idea. Whenever it is a diagonal matrix, count the non-zero elements. There are 3. Immediately declare rank is 3 and option C is the right choice. Question number 11. A transition matrix is given 0.7, 0.3, 0.6 and X is given. We know in a transition matrix, the rows add up to 1. So 0.7 plus 0.3 is 1. Obviously, 0.6 plus X should give me 1. 0.6 plus X. So what is X? 1 minus 0.6 and it is 0.4. Option C is the right choice. Question number 12. Which of the following is not an elementary transformation? Elementary transformation, what are all permissible? Within rows I can do or within columns I can do. Here row and column are mixed. So this is not valid. You can interchange a row. You can add or subtract multiples of one row with another row. Same way one column with other column. But here row is coming, column is coming, which is not permissible. So option B is not an elementary transformation. So my question is not an elementary transformation. So option B is the right choice. Question number 13. Row of A and row of AB are equal. Whenever row of A and row of AB are equal, our immediate declaration is the equations are consistent. They may have infinitely many or unique. That we do not know. That depends on the number of unknowns. But here they didn't mention about number of unknowns. The only condition is row of A equals row of AB. Whenever this condition is given, the only declaration is the equations are consistent. The system is consistent. Option C is the right choice. Question number 14. Row of A, row of AB, number of unknowns, all are equal. Then we will declare consistent because row of A and row of AB are equal. Consistent. It is again equal to the number of unknowns. It has unique solution. So consistent and has unique solution. Option B is the right choice. Question number 15. Row of A not equal to row of AB. Immediately we will say inconsistent, no solution. Whenever row of A is not equal to row of AB, inconsistent. So that is the right option. The right choice is option C. Question number 16. In a transition probability matrix, all the entries are greater than or equal to. We know in a transition probability matrix, this number and this number, as I add, it must give me 1. So for example, 0.6 tells me 0.4 must come. 0.2 tells me 0.8 must come. Always the total, say A plus B, should give me 1. So any of the element, this is for example I have given, any of the entries cannot be 1 or above. Obviously they are greater or equal to 0. So the right choice is C. Question number 17. It is a direct question from the formula. Number of variables in a non-homogeneous system Ax equal to B is n. So this tells the number of variables is n. The system will possess unique solution when row of A, row of AB and n all must be equal. Row of A, row of AB, n all are equal. So option B is the right choice for unique solution. Question number 18. The system of equations 4x plus 6y equals to 5, 6x plus 9. If I write it as ax equal to b form, it will be 4, 6, 6, 9 into xy equals 5, 7. Let me derive the rank of it. So here 4, 6, 5, 6, 9, 7. First row I can multiply by 6. Second row I can multiply by 4 and I can subtract. R2 becomes 4R2. I multiply this number here, this number here. 4R2 minus 6R1. 4R2. Let me multiply 4 times. 24, 36, 28. As I put minus 6R1. Multiply all this by 6. 24, 36, 30. Because I want minus, let me subtract. My answer is 0, 0, minus 2. So I get 0, 0, minus 2. So this is A, B matrix and this is equivalent to that. When I hide the last column, I get row of A. This is fully 0. Here one row is there. So row of A is 1. What about row of AB? I just leave it like this way. Here non-zero. Here also non-zero. So row of AB is 2. So we will say row of A not equal to row of AB. Therefore, inconsistent, or I will say no solution. So in this problem, either I can just by looking, I can derive like this. 4x plus 6y equal to 5, 6x plus 9y equal to 7. As I divide by 2 table, I get 2 times, 3 times, 5 by 2. As I divide by 2 table, 2 times, 3 times, 5 by 2. Here let me divide by 3 table. 2 times, 3 times, 7 by, I am dividing by 3 table, so it is 7 by 3. So this is shortcut method to check. Here both are same, here both are same, but here the numbers are different. So whenever I have same numbers in the left, right also I have same numbers, we will say infinitely many solutions. But left side it is same, right side it is not so. Even without calculating all this, from this itself I can say no solution. So obviously problems of this pattern, learn to say the answer even without working. So this is a complete working of the problem without working also, because just by looking I know they are multiples. Divide by 2 table, divide by 3 table. I get same numbers for x and y, but not so for RHS. Immediately declare the answer no solution. Option B. Question number 19. For the system of equations x, 2y, 3z, 1. Because it is a multiple choice question, let me directly write the matrix. 1, 2, 3, 1. Second equation 2, 1, 3, 2. Third equation 5, 5, 9, 4. We need to find the rank so that I can decide about the solutions. As I know this is A, B, the augmented matrix. Let me start deriving the rank of it. So this is First row, first element 1, write as it is. Second row, I can write R2 becomes here 2, here 1. So R2 minus 2R1. Whatever number is here, I will multiply. What is R2? 2, 1, 3, 2. What is 2R1? Multiply 2R1. Every number I multiply by 2. 2, 4, 6, 2. And I want to subtract. So put minus symbol. What is your answer? 2 minus 2, 0. 1 minus 4, 3 minus 6, 2 minus 2. So I get 0, minus 3, 0. Similar way, I want to find out R3. What is the number? 5. Here what is the number? 1. So I can say R3 is R3 minus 5R1. Let me write what is R3. So R3 is 5, 5, 9, 4. R1 we multiply by 5. So 5, 10, 15, 5. 5, 10, 15, 5. I just multiply R1 by 5. I want minus symbol. So subtract. 0, minus 5, minus 6, minus 1. As we simplify, let me write here. 0, minus 5, minus 6, minus 1. Now, I need to bring one more 0 here. To bring about one more 0, let me multiply this row. But here, minus 3 is same. So, I can divide by minus 3. Which one I am dividing? Second row, let me divide by minus 3. So, I get first row, no change, write as it is. Second row, we divide by minus 3. 0, minus 3 by minus 3, minus 3 by minus 3, 0 by minus 3. Third row, copy as it is. Now, to bring about 0 here, R2, multiply by 5 and then add it. So, we write R3 becomes R3 plus 5R2. R3 plus 5R2. What is R3? 0, minus 5, minus 6, minus 1. What is 5R2? Multiply R2 by 5. 0, 5, 5, 0. What is my answer? 0, 0, minus 1, minus 1. So we get first row 1, 2, 3, 1. Second row 0, 1, 1, 0. Third row 0, 0, minus 1, minus 1. Now it is echelon form. We have row of A. My answer, as I hide the last column, row of A. Here non-zero, non-zero, non-zero. Row of A is 3. Row of AB is also 3. I can immediately say unique solution. The word unique tells me only one. The word unique tells me only one solution. So option A is the right choice. Now, without using all this, I can directly decide about only one solution whenever determinant of LHS is not equal to 0. So, this is one way of doing with rank. Another way for only one solution. Find out the determinant of x coefficient, y coefficient and z coefficient alone. Ignore this. I am taking x, y, z coefficients. If my answer is not 0, when I find the determinant, I can immediately declare there is only one solution. It's an alternate trial which you can try yourself. Question number 20. If determinant A is not equal to 0, then A is a non-singular matrix. This is just by the definition. Whenever determinant A is not equal to 0, we call A as a non-singular matrix. Question number 21. The system of linear equations x plus y plus z equals 2, 2x plus y minus z equals 3, 3x plus 2y plus k equals 4 has unique solution. What do you mean by the word unique solution? Rank of A and rank of AB and number of unknowns are equal. That means rank of A must be the number of unknowns. How many unknowns are there? X, Y, Z. There are 3 unknowns. So what do I understand? The third order minor should not become 0. So make the third order minor 1, 1, 1. LHS, X, Y, Z coefficients I am writing 2, 1, minus 1, 3, 2, K. This must not be equal to 0 because the rank is 3. Third order minor should not become 0. If I expand plus, minus, plus. As I expand 1 into, hide the row and column, 1 minus 1, 2k. Minus 1 into, hide the row and column, 2 minus 1, 3k. Plus 1 into, hide the row and column, 2, 1, 3, 2. This is not equal to 0. As we expand 1 into k plus 2, minus 1 into 2k plus 3, plus 1 into 4 minus 3, which is not equal to 0. As we try to simplify, it is 1 into k plus 1 into 2, minus 1 into 2k, minus 1 into 3, plus 4 minus 3 is 1, 1 into 1 is. As we simplify, k minus 2k minus k, 2 minus 3 plus 1 will be plus 0. That is not equal to 0, or simply I will say k is not equal to 0. Out of the 4 options, k not equal to is my question. So not equal to 0 is the right choice. Question number 22. Cramer's rule is applicable only to get an unique solution when del is not equal to 0. So whenever you want unique solution, you can use Cramer's rule provided the determinant of the equation, that is del value, is not equal to 0. Question number 23. A1 by x plus b1 by y equals c1. First equation, a1 by x plus b1 by y equals c1. Second equation, a2 by x plus b2 by y equals c2. Given del 1, del 2, del 3, we need to find what is x and what is y. Let us try to apply Cramer's rule, because del 1, del 2, del 3 are all in determinants. We shall find out the solution using Cramer's rule. Del. What do I mean by del? I write the coefficients. I have a1, b1. Second, a2, b2. Let me find out what is del 1 by x, because in both the cases I have x in the denominator. So I can write del 1 by x. It is, instead of first column, I will write the RHS. C1, C2, B1, B2. Let me write what is del 1 by y. Again I have y in the denominator. So del 1 by y is, instead of y column, I will write the RHS. So what is x coefficient? A1, A2. Instead of this y column, we are writing the RHS, that is C1, C2. Now, what is 1 by x? It is del 1 by x by del. And what is 1 by y? It is del 1 by y by del. What is del 1 by x? C1 B1 C2 B2. In the given question, this suits with del 2. But del 2 I have B1 B2 as first column. Here it is second column. C1 C2 as second column. Here it is first column. So this and this are same, but the sign is different because we have interchanged the two columns. So 1 by x is del 1 by x by del. 1 by x, when I reverse, it is x, which is del by del 1 by x. X is equal to, instead of del, I can say a1 b1 a2 b2, which is nothing but del 1 in the question. Del is del 1. Del 1 by x is nothing but minus del 2. Similarly, I can calculate what is y. It is del by del 1 by y. What is del? Which is nothing but del 1. What is del 1 by y? Del 1 by y, I have a1 c1 a2 c2. I compare this with del 3. Del 3 and del 1 by y are same, but columns are interchanged. C1 C2 as first column, C1 C2 as second column. So this is minus del 3. As I substitute, it is del 1 by minus del 3. So the right solution I have x comma y equals minus del 1 by del 2 minus del 1 by del 3. Out of the 4 options, option D gives you the right choice. Question number 24. Determinant of A of order n is 3. Determinant of adjoint of A is 243. Then we need to find the value of n. We know the formula. Determinant of adjoint of A is determinant of A the whole power n minus 1. Whenever A is of order n. Here A, I have the order n. So determinant A the whole power n minus 1 gives me determinant of adjoint A. Given this value 243. Determinant A is 3 the whole power n minus 1. Let us try to raise this also as 3 power. 243, keep on dividing by 3. I do get 5 3's. As I divide 243 repeatedly by 3, I get 1, 2, 3, 4, 5. So 3 power 5 is nothing but 3 power n minus 1. Compare the powers. N minus 1 is 5 or n equals 5 plus 1, that is 6. Option C is the right choice. Question number 25. Rank of a null matrix. Null matrix is nothing but every element is 0. Something like this. Or I can even write third order and so on. In every case, the determinant value is always 0, whatever may be the order. So we will declare rank of null matrix is 0. And we remember rank of null matrix alone is 0. Every other matrix will have a minimum rank of 1. Only null matrix, that is 0 matrix, the rank is 0. Option A is the right choice.